Everyone, today we're gonna do trigonometric questions. So basically we have to solve for the value of theta. So if we can look at question number 1, it says 3 cosec theta minus 6 is equal to 0. They also give us the restriction, or you can call it a range, or I don't know what you can call it. But remember, range is when we talk about y-axis, and a domain is when we talk about x-axis. So when we actually talk about theta, I don't know what I should call it, but it's just a restriction. Yeah, remember, a restriction, when we talk about theta, we use quadrants. Yeah? So firstly, before I go to the question, I just want to remind you here. Let's say, for example, we want a cosec. So if we want cosec, we know cosec is equivalent to 1 over sine. So let's say it's cosec theta. Cosec theta is equivalent to 1 over sine theta. So sec theta will be equivalent to 1 over cos theta. Cos theta, and then cot theta, it will be equivalent to 1 over tangent. So these are just reciprocal of our normal trig functions, sine, cos, and tangent. But if it's cosec, that means it's 1 over sine. If it's sec, it's 1 over cos. It's like, that's, I don't know how you can claim it or how you can understand it, but these are identical. So cot goes with tangent, and then sec with cos, then cosec with sine. Okay, so now that is out of the way, let's get to the question. Okay, so before I go to the question, let's also explain the quadrant. So basically, we have a Cartesian plane, but this plane now we're actually gonna do it with what? With angles. So on our right here, so it's always our reference point. So the angle is 0, and then we have 90 here, and then we have 180, and then we have 270, and then we have 3. Okay, like I said here on the question, do you see that they give us an equation to solve for theta, and then they just restrict us to say theta it will be an angle between 360 and 0 degrees. So basically theta, it can be at any quadrant for this one. They say it can be between 0 and 360 is actually quadrant 1, 2, 3, and 4. Let's say, for example, if they just said theta will be, if the question was restricted to say now theta will be between 180 and it will be in 180 and 270, we will just know that our theta will actually be on the third quadrant and the fourth quadrant. So this is the first, second, third, equal to actually display that, because I can see on these questions everything here is theta is an element between 0 and 360, and 0 and 360 is actually all quadrants. So yeah, unfortunately I can't show you here, but maybe when we have another problem I will show you. Okay, so now let's go straight to the problem and let's solve the problem. Let's solve for the value of theta. Okay, so if we have a 3 cosec theta minus 6 is equivalent to 0. Okay, normally the advice that I will give you is that if ever you have cosec or sec or cot, just make sure you convert them to your normal trig functions, because on your calculator we only have cos, sine, and tangent. So we will not be able to find cosec theta. Okay, so on my equation I will just convert this one here. I know cosec goes with sine, but remember it is a reciprocal. So 3 theta, cosec theta will be equivalent to what? To 1 over sine theta. Then everything will still remain the same here. This is 6 is equals to 0. Okay, and then now I just do my math. I'm just gonna transpose this one and put it that side. So I'm gonna have 3. Remember 3 is over 1. So if you multiply fractions, what is at the top multiplies, and then what is at the bottom multiplies. So it's gonna be 3 multiplied by 1, which is 3. 1 multiplied by sine, which is gonna give us sine theta. Sine theta, and then when you transpose 6 and put it that side, it's going to be positive 6, and then here we have over 1. So if we have fractions that are equated, we know that we will have to do what? To cross multiply. So we cross multiply, so that means the sine of theta will multiply with 6, and then now 1 will multiply with 3. So we'll have 6 sine of theta is equal to 3. And then when you divide by 6, divide by 6, so that means your sine theta will be equals to 1 over 2, because remember 6 will cancel 6 here, and then 3 over 6 is going to be 1 over 2. And then now when we find the value of theta, you just do a second function. So it's going to be theta, second function of sine, 1 over 2. Then you just punch your calculator, you get the value of theta. So you just say second function sine 1 over 2. So the value of theta is going to be 30 degrees. Okay, so that is how you solve for theta. So you will normally do the same thing here for tangent. That means you're just going to transpose 4 to that side, and it's positive 4. You divide by 2, and then you find the value of x. Okay, so number 2, I think I can skip that one because it's very easy. You will be able to do it. So let's look at number 3. So number 3 is cos 2a plus 4 is equals to cos a. Okay, so this one we need to tackle because it's a little bit challenging. Okay, so let's see number 3. Number 3, we have what? We have 5 cos a plus 4 is equals to 3 cos a. Cos a. Okay. Okay. So here we will first start with this what cos 2a. Cos 2a is actually an identity. Okay, so when this is an identity, we're just gonna substitute its identity here. But remember, its identity, we want to solve for the value of a. So its identity is gonna be what? We're gonna choose this one. You will have to know different types of identities, and then you know suitable one for the identity. So the identity of cos 2a is gonna be cos. Let me just show you identities of cos 2a. Cos 2a has an identity which is cos squared a minus sine squared a. Then it also has an identity 2 squared a minus 1. And then it also has an identity of 1 minus 2 sine squared A. Okay, so basically from all these identities of cos, you just have to pick a suitable one that will actually make your equation solvable. So let's say we choose the first one, cos and sine. If we make cos and sine, that means it's just going to be complicated. We're making it complicated because we have cos at this side. And then let's look at the second one. The second one is the applicable one because it only has cos squared. And we only have cos and we also have cos on that side. So this one is an applicable identity that we'll use. So let's look at the third one is 1 minus 2 sine squared. If you put sine here and cos, if you have cos and sine, that means the problem will be more complicated. So we're going to choose the second identity. Okay. So now in place of cos 2a, we are just going to place what? 2 cos squared a minus 1. And then it's plus 4 equals to 3 cos a. Okay, let me just erase all these identities because you are not going to need them. Now what you have to do, you just have to simplify. You're just going to say 5 multiplied by 2 cos squared a is going to be 10, 10 cos squared a, and then 5 multiplied by negative 1, 5 multiplied by negative 1 is going to be negative 5 plus 4, all equals to 3 cos a. Okay, so cos a, we're just going to treat it as x. We see now we're going to have a quadratic. It's cos squared, it's like x squared, x, and constant. So it's going to be a quadratic equation. So I'm just going to transpose this one here and put it on the other side. So you're going to have 10 cos squared a. That one, when it comes to this side, is going to be minus 3 cos a minus 5 plus 4 is going to be what? It's going to be minus 1. Okay, so remember now we have what? We have cos squared a, cos a minus 1. This is a quadratic equation. We can use a quadratic formula. So, but now remember this is not your x squared. So the value that you're looking for is going to be what? A cos of a. Cos of a will be equals to, we substitute the quadratic equation, minus b plus or minus square root of b squared minus 4ac all divided by 2a. And then we just substitute the variable. What will be the value of b? The value of b is coefficient of x, which is now cos a, which is negative 3. So we're just going to substitute our b there. B is what? Is negative 3 plus or minus, and then the square root. What is b? B is negative 3 squared minus 4. A is 10, and then c is negative 1. All divided by 2, and the value of a is 10. So you're just going to put everything into your calculator. You get the value of cos a. Okay, let me just punch this here on the calculator very fast. It's negative 3 into negative 3 plus square root 3 squared minus 4 into 10 into negative 1 all 2a, all 2 multiplied by 10. So the first value of a is going to be 1 over 2. When you put minus there, when you put minus, cos theta is going to be how much? Cos theta is going to be negative 1 over 5. Okay. Okay, so I'm just gonna erase here at the top so that I solve fast. Okay, yeah, I'm sorry for that. Okay, so that means for the first, we want to solve for the value of a. We're gonna do a what? A cos second function. Sorry. So remember, we want to solve this problem, so we must do a second function of cos so that we get the value of a. So we say a is equals to what? Is equals to second function of cos, uh, or a will be equivalent to what? To of what? Over 5. So the value of a here, it will be how much? So second function cos 1 over 2 is going to be 60. Okay, so now if ever we get what? We get, we do a second function, and inside the second function, our answer is a negative answer. We must just check now to say where cos, not actually here where we put on our, yeah, but it doesn't matter even if it's on our trig here inside the angle, or even from here we check, they say cos of theta is negative. So where is cos of theta negative? You just check your quadrants. Remember, on your quadrant it's going to be cast. I'm sorry, so when you do your cast, it's that from the fourth quadrant, so it's going to be cast. All right, cast. So cast means that on the first quadrant all the trig functions are positive, and on the second is only sine that is positive, on the third is only tangent that is positive, and on the fourth is only cos that is positive. So now it's when this problem says that cos of theta is negative, cos of theta will be negative where? On the second and third quadrant. Okay, so that means the value of a that we get here is a reference angle. So it's just going to be a reference of a because it's negative. So if it's a reference of a, let's just put it here. It's gonna cos of theta, we don't put the negative sign, we just say 1 over 5. That 1 over 5, it gives us a reference of a, which is 78.46 degrees. So remember, 78.46 degrees is actually on the first quadrant, is our reference angle. So if ever we want what we want, where tangent is what? Where tangent, where cos is negative, our theta can either be, our a can either be 180 minus the reference angle, which is 78.46, or it can either be 180 plus, which is the third quadrant. Cos will be a negative. And then you just punch in your calculator there to get the value of a. When you say 180 minus 78.46, so the answer will just be 101.54 degrees. And then when you put plus there, and you put plus, it's going to be 258.46 degrees. Yeah, so that is the values of a that you have. You can possibly have these three values because the range saying that the value can either be between 0 and 360. So all these angles, they fall between 0 and 360, so they are all applicable, all three of them. Okay, so now let's look at another problem. I don't know if there's another interesting problem here, or we can just skip to do maybe 2 or 3 maybe 2 proof questions, and then we just end the video. Okay, let me just check a question that will be different here. So here is cos squared minus cos. So here we can see that we can divide by cos. When you divide by cos, it's going to be -1. You divide by 2, you will get it very easy, this one. And then this one here is cot minus cosec squared. Okay, so cot is going to be 1 over tangent, and cosec is going to be 1 over sine, and it's all squared. So this one it looks like it's a little bit challenging, so I just give you this challenge so that you can do it on your own. Maybe when we meet, we will do it again together. And then this one is a sec, and then it has tangent. Yeah, actually the rest of them you will just try to do them, and then I will just do them with you. I just want to do at least 2 problems of proof here. So let's look at proof identities. So the first identity is the identity that says square root of 2 plus 2 cos of x. Prove that 2 plus 2 cos of x is equals to 2 cos x. Okay, so remember, when you prove, you're just going to check the simplest side. So the simplest side is the right hand side. That means now you're going to take what? You're going to take this side here that is complex, and then you do what? You just simplify this one to check if you will get the same answer as this. Okay, so you will say, okay, on my left hand side, I'm going to simplify on my left hand side. So on my left hand side I have a square root, so inside I can see there I have a common factor of how much? A common factor of 2. Okay, but if I take out a common factor of 2, how will that help me? Okay, so I can see that if I take out the common factor as 2, that is not going to lead me anywhere. Or that means I just have to just remove the square root here. But when I remove the square root, remember this is an equation. What you do on your left, you must also do on your right. So I'm just going to square there and square here. So that means the square root will cancel the square root here. But before I solve here, on my left hand side I will have 2 plus 2 cos x, and then on my right hand side it will be 2 squared, which is 4, and then cos squared x. Okay, so if it is like this, I can do what? I can show that I can prove now my right hand side can be equivalent to my left hand side, because I also saw that on this side there's nothing that I can do, or maybe I can take out a common factor, but I don't necessarily have a lot of things to do here. So I'm just gonna solve my left hand side, so my right hand side actually. So I'm just gonna say my right hand side. In my right hand side I have what? I have 4 cos squared x. So how can I simplify? Okay, so here I actually can see the way that I can actually prove to say this identity is equals to this one. I don't know, yeah, but when we meet I'll just look at this problem, and then I will come up with a solution for it. Or actually we will meet tomorrow, and then let's try to look at everything. But this first identity, I don't see any how I can make this side be equals to this side, or this side be equals to that side. But I will just check to confirm how to do it. Let me just end the video here, but I promise tomorrow we're just gonna meet and tackle everything. Thank you.